Hello, we are here for one more lesson of this T-Flex CAD training course, and the topic for today will be the parametric sweep. This is a very special function. This parametric sweep is a variation of the common sweep, and it's used to create bodies with complex surface geometry. The idea is the same, so we sweep a profile along an arbitrary, specially defined spatial trajectory, and we can connect this variation by functions and parameters and control those positions in space by those functions. This is a little special lesson, and in this particular case I think it is very convenient that you can check the theoretical lesson, because there are a lot of details that allow you to understand better what is going on and how to work properly with this. But anyway, let us open one example that T-Flex has, and we build a parametric sweep with this shape with this function. So the function is for sure in parametric in this function here by parameters. So you know already sweep, the parameters, and we have another one called the pipeline, so by parameters. This is quite similar. There are a couple of variations. That is why it is important to check the theoretical side. But for a quick understanding of this, we've created a couple of variables. In these variables, I've created one called Z that has the value 1. And this is what we call as the current instance or the copy number. This is the number of items that are going to be copied along this sweep. And I have other functions. This one controls the dimension of this spring, and this controls the number of items that are going around. And then on the sweep, we have this kind of dialog box, because we have this dialog box controls several things, and we have two main types of operation parameters, which are the driven parameters and the driving parameters. So these are the driven variables around here. And this is the number of copies. This should be connected always to the number of copies that we want to do, and point this to a variable. So I'm pointing this to the variable which I called number of copies. And I want to copy this 360 times, okay, to have a full spectrum of the angles. And then I have to control the position, and this first dialog controls the position of the coordinate system in the origin, and this 3x, y, z controls the direction vectors that are going to be used. And as you can see, we relate. These are mathematical functions which I will not explain here, but these functions control what is created after. For example, if I say I don't want to copy I don't want the copy number to be 360, I want to be 180. Let us see what happens. You see that I only build half of this part. So 360 again. For example, I can go here also the Z2. If I say Z, so it will be only 1. it will be a much more um, closed shape, because if you remember, the Z it's controlled also by the value. So in fact, this is a relation of the variables. So Z twice, and we can apply the functions and connect all these variables to control what is going on. So define this, and we can go to the parameters, for example, changing the value of the variable. So instead of 100, 200, and should be more bold. And okay, that's it. So there are a lot of possibilities with this parametric sweep. This is not very easy to explain in this video. I truly believe that it was very beneficial for you to consult our theoretical course, but anyway, this is one of the areas where we are going to publish additional videos to explain this topic of the parameters and to connect this with some functions with very clean examples, so that you are able to see some types of parametric sweeps that we are able to do with this command. This brief example, I hope that maybe not so clear as usual, but at least that open your mind to this command, and with some very global ideas of what we can do with this parametric sweep.